All right, scholars. Sorry, I'm a little irritated with the notability. It keeps changing. It's like it's so temperamental. Give me just a moment. All right. Well, that's the best I can do. I can't get that to behave the way it normally does. All right, scholars. Welcome. We are rapidly entering the home stretch, right? So today, we're going on to the last of our new content, which is Chapter 6, Further Topics in Algebra. Oh, oh. And we're going to be working on Section 6.4, Systems of Equations in Two Variables. Let me see this as far as announcements. Let me see if I can pull up a calendar. Right here. Thanksgiving is seriously next week? Jeez, that's so fast. Okay. So this week we'll proceed like normal, right? We're going to be working on section 6.4. Next week we'll definitely meet on that Monday. We more than likely are not going to meet on that Wednesday. At worst, I'll update you guys as far as that. Right. You know, obviously because we're remote, you can start your travel plans, and just in case we do meet, just be ready to log in to get your attendance. But I'm not going to make a big deal about that Wednesday. Even if we do meet, it's remote, so it wouldn't really stop you. Uh, yeah, so this is the last of the new content. As usual, feel free to either unmute yourself to get my attention or type in the chat. Now, the audio, I'm not going to be able to hear your audio right now because I'm testing out a microphone, but it doesn't have like an earpiece. It's just a microphone, so it's like cutting off my audio. But feel free to type in the chat, and I'll monitor the chat. And again, I'll get anybody that's coming late around the 15-minute mark. So if they haven't gotten into the recording by now, then they need to wait until the 15-minute mark. So if you're in communication, just say, hey, I'll check it again around 15 minutes. Tell them to just wait because I check it periodically. um, and then as far as the final, again, I haven't gotten any update as far as that concerns. So right now you can anticipate it to be similar to how we've been doing our exams, 1, 2, and 3, right? So more than likely I'll create the exam and it'll be similar to how we've been doing it. But if anything changes, I will notify you and let you know. So section 6.4 is a system of equations in two variables. A few objectives. 1, verify solution to a system of equations. 2, solve a system of equations by the graphical method. 3, solve a system of equations by the substitution method. 4, solve a system of equations by the elimination method. And 5, solve applied problems by solving system of equations. A few definitions. A set of equations with common variables is called a system of equations. If each equation is linear, then it is a system of linear equations or a linear system of equations. If at least one equation is nonlinear, then it is called a nonlinear system of equations. Here's a system of two linear equations in two variables. Okay. A system of equations is sometimes referred to as a set of simultaneous equations. A solution to a system of equations in two variables x and y is an ordered pair of numbers a and b such that when x is replaced by a and y is replaced by b, all resulting equations in the system are true. The solution set of a system of equations is a set of all solutions of the system. I think this is just, I feel like this is fairly straightforward. This will, after we work a couple of examples, I think it'll start to sink in, if it hasn't already. Verify that the ordered pair 3, 1 is the solution to the system of linear equations, right? So let me think. That would be nice. Okay. So all this is saying is that when x is 3 and y is 1, it should make both equations true, right? So notice that 2 times 3 is 6, minus 1 is indeed 5. 3 plus 2 is indeed 5, right? So 3, 1 is the solution to the system because it makes both equations true. Let me check on you guys in Zoom. Let me get these gentlemen. The chat looks good. Okay, we should have a total of that. Oh, I'm gonna have to stop. Let me try low power mode. Ooh, yeah. I don't think I can use this mic right now. My battery is way too low. Yeah, let me scrap this. I have an adapter, but I don't know where it is right this very second. So, I have to forego that. Do it the way I normally do it. I thought it would last a little bit longer. I was sadly mistaken. All right, so I use the graphical method to solve the system of equations. Okay. Um, I think I'm going to actually use a graphing utility instead of doing it by hand. I feel like we should have some level of proficiency of graphing lines. We could graph the intercepts. I'm going to use, I could use my calculator. I'm going to use this, I'm going to use, I think I'm going to use GeoGebra. All right, we can use Desmos. It doesn't really matter. They're the same. Let's see. Okay. Uh, let's do Desmos because I know that's one that a lot of students use. So this is a free graphing utility that when you go to the site, it's just like this. You don't have to log in or anything. I'm just going to click on graphing calculator. Okay. And then something like this comes up. I'm going to type it exactly how I see it, and let's see what happens. So if we say 2x minus y equals 5, okay? And then we have 2x plus 3y equals 12, all right? So this looks accurate, right? I think that's why I was pausing before. I was trying to think of like something like this. Anyway. So when we graph these two lines, we see that they cross. Let's see if we can find. Can we write that as a fraction? Is correct. 2x plus 3y equals 12. 2x. Oh, it's not right. Right. This needs to be a 4. I was like, why are we getting those weird numbers? There we go. I think that's much better. Okay. Yeah. All right. So I'm able to click on that point and see that they crossed at the order pair 3, 2. All right. See how quickly I just typed it in? Wherever they cross is a solution. All right. So we're saying that when x is 3 and y is 2, it makes the system true. Oh, you know it got to be true because it rhymes, right? All right, so 2 times 3 is what? 6 minus 2 is indeed 4. 6 plus 6 is indeed 12, right? So this order pair 3, 2 is indeed the solution to the system. And I think we already have this typed up. So they graphed by plotting the intercepts, the x and y intercept. Now, my recommendation, oftentimes I feel like it's easier to find the y-intercept first. I mean, it might be about the same in this example. So again, we used Desmos, and we were quickly able to generate the solution. Okay. And then check, right? And we did that as well. So the solution set up a system of 2 linear equations and 2 variables can be classified in one of the following ways. First, we can have one solution where the system is consistent and the equations are said to be independent. All right, so they cross at one point or a finite number of points. The system is consistent and the equations are said to be independent. In the second case, we can have no solutions. The lines are parallel and the system is inconsistent. So they never cross. There's no solution. They have the same slope with different y-intercepts. So then there's no solution. And then we can have infinitely many solutions. The lines coincide. The system is consistent and the equations are said to be dependent. So this generally happens when one equation is a multiple of another. Okay. So to solve the system, substitution method. Okay. So now we saw how quickly we can do that by looking at the graph, but I want to showcase sometimes we don't have the luxury of looking at the graph and getting it so easily. 1 and 2. Okay. Ooh, it's steady going down. That's going the wrong way. I don't know if we're gonna make it today. Oh, I had it plugged, but I don't know. It's charging really slowly. Let me grab. I gotta organize my stuff. Okay, I'll use this. This will work. Okay, substitution method, right? So in the substitution method, what we're going to do is solve one equation for one variable and then take that and plug it into the other equation, right? So in this example, it looks like solving for y in equation 2 might be the most simple. So if we add 2x to both sides from equation 2, we'll get y equals 2x plus 9. So then we're going to take this and substitute it in equation 1. So we'll get 2x minus 5 times y equals 3. Notice I replaced my variable with a blank set of parentheses, and then what goes into the blank parentheses is the substitution. Okay. So now we got one equation, one unknown, so we can solve. Every time we have an unknown, we need an equation. So we have 2 unknowns. That's why we're given 2 equations so that we can solve it. Okay, so then we'll get 2x minus 10x minus 45 equals 3. So 2 minus 10 is a negative 8. Okay. So we'll get negative 8x equals, now if we add 45, it's 48. So then x equals 6. Oh, well, that's just x. Okay, so then we need to go back and find y. So kind of work over here. So then y is going to be 2 times 6 plus 9. 12 plus 9 is 21. Sorry, that's not right. Not 6, but what? Negative 6. So then if that's negative 6, this is negative 6. That's a negative 12. What is it, negative 3? Okay. Okay. So our claim is that the ordered pair negative 6 comma negative 3 is a solution to the system. Okay. Let me see, when x is negative 6, we get negative 12 plus 15 is 3, so that checks out. Negative 3 plus 12 is indeed 9, right? So this ordered pair makes both equations true, so it's a solution to our system. And you know, let's just, since we can, let's just check it here real quick. All right, it will take like 2 seconds. Let me get rid of these 2 guys. Come on. There's 1, 2. Okay, that's fine. So if we say 2x minus 5y, 2x minus 5y, and again, this is desmos.com equals 3. Okay. And then we're going to do y minus 2x equals 9, y minus 2x equals 9. And then the order pair, they cross at negative 6, negative 3, same thing we got. Okay. All right, so I showed you how to do it by hand, and I showed you how to do it in an instant. So you have at least 2 different ways to check this. I think I got that already. Yeah, I think we're good. Does somebody have 2? Somebody might be in here. Oh, who am I missing? Is there a double? Does somebody have a double? I'm missing somebody. Let me see. I'm gonna have to let it go. I don't know who the extra person is. Okay. Yeah, I don't know. Oh. Actually, I think I know what's going on. Okay. We're okay. Okay. All right, so I think we got that one. Let's keep going. I don't think we got all this. Okay. Okay, so here we're asked to solve the system. So we could try, let's see, we could try substitution again, right? If we solve for one variable in one equation. So like for instance, if we solve for y in equation 1, we'll get y equals 3 minus x. Right? So then if we plug that into equation 2, we're going to have 2x plus 2 times y equals 9. Okay. We can distribute that 2x plus 6 minus 2x equals 9. A number plus its opposite as 0. If we subtract 6, we get 0 equals 3, but that's false, right? So notice in this example, when we tried to solve, all of our variables canceled out, and we were done with a false statement. So this is an example of an inconsistent system. These are going to be two parallel lines with different slopes, so they'll never cross. So and we can actually confirm that. Like 2 seconds. So then if we say x plus y equals 3, and then 2x plus 2y equals 9, 2x plus 2y equals 9. All right, see, two parallel lines, they'll never cross, so no solution. Solve the system, okay? We can still do the substitution method here. It looks like solving for y in equation 2 might be the most simple. So if we add y and add 6, we'll get y equals, y equals 6 minus 2x. Okay. And then take this and plug it into the first equation. So we'll get 4x plus 2 times y equals 12, but our y is 6 minus 2x. So then we have one equation, one unknown, so we can solve. We'll get 4x plus 12 minus 4x equals 12. A number plus its opposite as 0. If we subtract 12 from both sides, we finish with 0 equals 0. This is a true statement. So that means we have infinitely many solutions, right? So this is an example of lines that coincide. One equation is a multiple of the other. If we say equation 2 times negative 2, we get equation 1, right? So then the way we write these solutions, there's infinitely many solutions that take on the following form. Whatever x we choose, the corresponding y is going to take on the form 6 minus 2x. And so then this is how we capture the infinite number of solutions here. So then you could check if you choose your favorite x value, find the corresponding y, it'll make the system true. Okay. Like for instance, when x is 0, a corresponding y is going to be 6. So then the ordered pairs 0, 6 is going to work in the equation. Notice that 6 times 2 is 12. Negative 6 is equal to negative 6, right? When x is 1, the corresponding y is what? 4. So then 4 plus 8 is 12. Negative 2 minus 4 is negative 6, right? So again, this is how we capture the infinite many solutions in this example. And then the solution sets are going to take on the form x, 6 minus 2x, right? Okay, so we've seen several different ways of solving a system of equations. I think the first way that we explored, first thing we did was we verified a solution to a system. Then we looked at solving a system using the graphical method. Then we looked at solving the system using substitution. Then we saw some of the different types of solutions that we'll get, where we have a consistent system, where the equations are independent, or we have an inconsistent system, right, where you had two parallel lines, or or the example where we had dependent equations. One equation was dependent on another. Basically, one was a multiple of the other, right? So we had infinitely many solutions. So here we want to look at this technique called the elimination method. With the elimination method, our goal, we want to pick a variable, either x or y, and we're going to multiply one row or one or both rows by a non-zero number. The goal is for one of the variables to have the same coefficient with opposite signs. So now looking at this, it looks like x might be easier to work with just because the numbers are smaller. Or actually, because the y already has opposite signs, I'm going to do y instead. So my goal is to get the coefficients to be the same with opposite signs. I think the least common multiple is 12. So what we can do, we're going to multiply the top equation by 3. So we're going to say times 3. And we're going to multiply each term by 3. And then equation 2, we're going to multiply by, sorry, not by 3, by 4, right? So this one, this is going to go here. The second equation by 3, the first equation by 4, right? And we're going to distribute a 3 across here, all right? So the goal, we're trying to get this to be plus or minus 12, okay? So now if we account for those changes, 4 times 2 is 8x, 4 times 3 is 12y, and what is that, 84. 3 times 3 is 9x, 4 times 3 is a negative 12y, 69. Okay. So now what we can do is add the two equations together. So a number plus its opposite, these add to 0. 8 and 9 is 17x. What is that, a 3? Carry the 1, 15, 153. There it is, 9. I was going through my numbers trying to find the multiple, right? 9. So I think 9 times 17, 90 plus 63 is 153, right? So then x equals 9. That's just our x. So then we need to go back and solve for y. I'm going to use equation 1. So we plug 9 in for x, we'll get 18 plus 3y equals 21. Then we'll get 3y equals 3. So then y equals 1. Okay. So then our claim is that the order pair 9, 1 is the solution to the system. Okay, let's see. So 18 plus 3 is indeed 21. 27 minus 4 is indeed 23. Let me check on you all on Zoom quick. All right. Okay, I think we got all of this. Oh, we're actually doing pretty good on time. Okay, solving a nonlinear system by linearizing substitution, right? So we're gonna solve this system, but we're gonna use a technique. It's called U substitution. So we're gonna let U equal 1 over x, and we're gonna let V equal 1 over y. And we're going to make those substitutions. So then if we make those substitutions, we're going to get what? 2u plus 5v equals negative 5. And then we're going to have 3u minus 2v equals negative 17. Okay. So now we're back to a linear system of equations in two variables. Oh, I think I'm going to try to cancel, do my elimination method. I'm going to try to eliminate the u. So if I'm going to eliminate u, we're going to multiply that first equation by 3. And we're going to multiply the second equation by negative 2. Okay. So then 3 times 2 is 6u. I don't know what I popped up. Let me see. 3 times 5 is 15. Equals a negative 15. Okay. And then negative 2, so 3 times 2 is negative 6u plus 4v. What is that? 34. So now if we add the two equations together, a number plus its opposite, these guys add to 0. Let me see. Is that 19v? So 15 and 30 would be 15, 19, right? So equals 19. Divide both sides by 19, and we get v equals 1. Okay. So then if v equals 1, I feel like I'm going to use equation 2. Right? So then 3u minus 2 times our v, but our v is what, 1? Equals negative 17. So add 2 to both sides. We get 3u equals what, a negative 15? Divide both sides by 3, u equals negative 5. Okay. So then what we need to do is reverse substitute, right? So if u is negative 5, that means 1 negative 5 equals 1 over y. Sorry, that's supposed to be an x, right? Right here. I'll do it in purple so you can see it. Or I'm trying to find a color. It's supposed to be 1 over x. Let me back up. Okay. So now if our u is a negative 1 over 5, so we have negative 5 equals 1 over x. If we cross multiply and divide, x equals a negative 1 by 5. Okay. And then for our v, we got 1. So 1 equals 1 over y. Cross multiply, y equals 1. Okay. So our claim is that the solution to the system, I feel like something is off, but we're going to go with it. Our claim is that the solution to the system is a negative 1 by 5, comma 1. Okay. Let me see. 2 divided by 1/5 is going to be, that's going to be a -10, plus 5 is indeed -5. That's going to be a -15 minus 2 is -17, right? So this order pair makes both equations true. So this is the solution to the system. Okay, let's hang out for like a little, right at about 10 more minutes. And we have almost 10 slots remaining. So that's just pretty much on time. Okay, I think we did all this. Hopefully we got one more example. Solve for X and Y. I think we got these results and we checked them. Okay. So this example, we're asked to find the equilibrium point if the supply and demand functions for a new brand of digital video recorder, DVR, are given by the system, okay, where P is the price in dollars and X is the number of units. Let me see. The supply and demand functions. So P is the price and X is the number of units. Equilibrium point. So the equilibrium point should occur when the supply is equal to the demand. So basically when equation 1 is equal to equation 2. So since we've already solved for P in one equation, we can just plug it into another equation. So I'm going to plug equation 1 into equation 2. So then that will give us 60 plus 0.0012x equals 80 minus 0.1238x. If I add that 0008x to the both sides, I think it gives me 0.002. Subtract 60 from both sides, we get a 20. That's what, 2 over 1,000? So if we divide both sides by 0.002, it becomes what, 1,000 over 2? So 500 times 2, 20. So 10,000 DVRs. So we need to produce and sell 10,000, and then we need to see, okay, at what price in order to reach equilibrium. Okay, so then if we take this 10,000, I'm going to plug it into 4 times. I'm just going to plug it into the second equation, all right? So then our price is going to be 80 minus, now, here, let's just write it, 0.1238 times 10,000. So we move the decimal to the right 4 times. 80 minus 8 is 72. So then the price should be $72 for each DVR. So if we produce and sell 10,000 DVRs sold at $72 each, that's going to be our equilibrium point. So that's when we turn back to 0. So then once we sell one additional, anything above 10,000 units sold is profit. Anything below 10,000, then we're paying out of pocket. Okay, substitute the value from P in equation 1 into equation 2 and then solve the resulting equation. So we need to produce and sell 10,000 units. To find the price, P, back substitute, you get 72. So the equilibrium point is 10,000, 72. You can verify that this point satisfies both equations. Okay, we are a little bit early. A lot of bit early. Let's hang out for like 5 more minutes. I don't want to keep you much longer. Let me work an example or two. Ooh, if my battery allows us to, just give me a moment. Let's hop. Yes, go ahead. Let's go here. Somebody have a question? Yeah. Okay. It's like we'll hang out for like 5 more minutes and I'll let you go. Allow. It's going to be this one, this one. Okay. And then all the way at the bottom, 6.4 system of equations in two variables. Let's see if we can do this quiz. Let's try the quiz just to be different. So we're going to start it. We got a few minutes, right? So let's see. It says solve the system of equations by graphing. So I'm actually just going to use my Desmos like we did before. Okay. All right, so we got x minus y. X minus y equals -8. And then we got x plus y equals 10. X plus y equals 10. We can see the cross up here at 1,9. Looking at this, I guess I'll graph it, but we got 1,9. This settings off. One, 9, and I think we still have to graph it. Let me choose this. Let me see, in the first equation, let me see, when x is 0, y is 8. When y is 0, x is -8. I think these are good, okay. And then in equation 2, when x is 0, y is 10. And when y is 0, x is 10. That looks good. So then we can see that they cross at 1,9, right? Which is the same result that we got. Oh, man. I don't like that as a quiz because we can't see it until we submit it. We got time for at least one more question. Determine whether the following system is consistent or inconsistent. I'm just going to look at the graph in the interest of time. Okay. X plus 4y. X plus 4y equals -5. Now, in that previous, I probably should have just checked it. 4x minus y equals 4. Okay. Now, see, notice that this one doesn't cross at a clean point. Like we get this decimal. Let me see. Determine whether, if the system is consistent, determine whether the equations are, okay, do not solve the system. But based on this image, right, they cross at a single point. So we say that they are consistent and independent. All right. So we're going to go with B. Got time for another. Solve the system by the substitution method. I'm just going to use this just because I can. In the interest of time. 4x minus y, 4x minus y. Again, we don't always have this as a luxury, but when we can, I don't see why not. 8x minus 2y equals 11. Okay. Ooh, the parallel, right? So it should be C. 4x minus y equals 8x minus 2y. Okay. So empty set. No solution. Maybe we can finish since we got 2 more questions. Solve the system. Okay. I'm just going to look at the graph. See what we can get out of there. 2x plus 5y equals -1. X plus 6y equals 3. X plus 6y equals 3. Okay. So they do cross. What point is this? -3, 1. So our claim is that the solution -3 here. We can check this one. -3, 1. Oops. Yep. So that's going to be a -6 plus 5 is indeed -1. -3 plus 6 is indeed 3, right? And we got one more. Let's just go ahead and do that last one. Mrs. Burke invested 25,000 into two accounts, one yielding 6% and the other yielding 8%. If she reaches a total of 1820 in interest at the end of the year, how much did she invest in each account? I think we're going to use simple interest. So I'm going to take some notes here. Okay. In interest, right? So the total interest is going to be the interest from the first account plus the interest from the second account, right? So she has some unknown amount in the first account. That's going to be a principal. The rate is 6%. So we're going to say times 0.06 times 1 year plus some unknown amount in the second account times, and that rate is 8%, 0.08. Okay. So that's one equation. I need another line. Oh, and then the total. So if we say the interest earned from the first plus the interest earned from the second was 1820, okay? I'm going to just use this for my second equation. And then however much she deposited in the first account, we're going to say that that's X. So she deposited X amount into the first account plus we'll say X plus the amount in the second account equals 25,000. So then what we can do is solve for Y in the second equation and plug it into the first. All right. So up here, our Y is actually 25,000 minus X. So I'm going to change this Y to 25,123 minus X. Trying to get you guys out of here. Okay, we have one equation, one unknown, so we can solve. I should have probably written it out. I'm being a little bit lazy. Let me see. Okay, let me see. I'm going to set all this to 0. So I'm going to say minus this equals 0. Let me think. So I feel like I need a calculator. Oh, you know what? Let's back up. Let's just look at the graph. Let's see if we can get it from the graph like we did all the others, right? So we know one equation. Let me see. Initially we had 0.06x plus 0.08y, and that was equal to 1820. Okay, we're just going to let that be for now. And then we also had x plus y equals 25,000. Okay. All right, so obviously we got to change our windows so we can see this. I'm just zooming out so I can see something. Oh, 25,000, right? Keep going. There it is. Okay. So we had to change our window. And what's this point of intersection? Boom! You know? So I think what we're saying is that 9,000 at 6% and 16,000 at 8%. I'm just going to go with that just in the interest of time again, because I'm just trying to get you guys out of here. So I started to solve it. And again, I probably should have written it out, but I'm rushing and I'm just trying to get you guys out. So then I was like, wait a minute, we can just do the same thing we've been doing all day, right? So you can see we typed in both equations and then we looked at the point of intersection, but we did have to zoom out, right? So I think that was pretty smooth. Let me get this to work. So I'm gonna clear all this out. So our claim is that one is at 9,000. And then I think this one was 16. Again, and I'm just rushing. I'm going to go with it. So, okay. Going to submit the quiz. Cross the fingers. Submit the quiz. How do we do? Woohoo! Right? Because obviously I still make mistakes. I'm still a human being. All right, gentlemen. Are there any burning questions before we go our separate ways? See how quick we did that quiz in under 10 minutes, right? Okay. If there aren't any burning questions, we're going to go ahead and end the session here. Let me see. So on Wednesday, we'll do as much of the corresponding homework with this, and then next week we'll start reviewing for our final. All right. And so on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, gentlemen. And I'll see you Wednesday, same time, same place. Take care, guys. Peace.